going to talk about conditional structures and Boolean logic. Boolean logic is the foundation for computer science, and you will use it from now on as long as you're in the computer science field. So it's very important that you all understand how Boolean logic works and why it's important and where you can use it, and finally how to use it. For example, if we want to compare something, we need to use some kind of logic. And in Python, they've enabled all the logical operators or relational operators that you've used in mathematics. Since elementary, for example, we can compare if the number 4 is greater than 5. And then Python returns whether it is or not. Of course, it's not, so it returns false. We can compare if 4 is greater than 3. Greater than 3, and it's going to return true. We can also compare if a number is equal to itself, and Python will return the answer for us, in this case true. We can also compare if a number is greater than or equal to a number, and we can compare if a number is less than or equal to a number. We're demonstrating this using the Python interpreter. We can also compare if a number is equal or not to a number. So 4 not equal 3, yes, it's not equal, so it returns true. If we can do this with, we can use relational operators with literals, in this case integer literals, then we can certainly use it with variables. So we're going to create a Python script file. And we're going to set a value equals to 2, and then we're going to set another value equals to 1, and then we're going to ask Python to print the result of x less than y. So we're asking Python, print me the result of x less than y. So let's go ahead and run this program. We're going to save it as sample3, and then we're going to run it. So just to review, we create a variable, assign it the value 2, we create another variable, assign it the value 1, and then we're asking Python, is x less than y? What happens? No, right? 2 is not greater than 1. So as you can see over here, Python returns false. If we can do that, then we can also ask Python, is it greater? Is x greater than y? And then we run our program, and Python returns, yes, it is. And we can do this with the greater than equal, ask to save, and we can ask Python, is x equal to y, or is 2 equal to y? And then we run it. Right, so here we're just creating a relational statement. We're just saying compare x to y, and the symbol is going to tell Python what kind of comparison we want to do. So it's important that we understand this. We can also ask, like we did before, is it not equal? So if we want to do that, we ask Python, is it not equal to? And then we're going to run it. Right, it's not equal, so it returns true. So this is the foundation for building conditional structures. A conditional structure is an if statement. A conditional structure helps a program build logic into it. For example, we're gonna go ahead and erase this. Our regular pay, we're salespeople, is $1,000, and we will collect a bonus if sales greater than a number. So say we have to produce more than $5,000 in sales, then we get a bonus. So then the bonus is $500. Simple example. So then in Python, well, you know what? Let's make it a little interesting. We'll ask the user for input. So we're going to say float input enter sales. And then what we're going to do is we're going to compare the sales to 5,000. So if they sell at least $5,000 of merchandise or more, then they qualify for a bonus. So then we'll create another variable, total pay equals 1,000. So then we're going to say if sales greater than or equal to 1,000, then total pay equals, I meant to do this regular pay, total pay equals total pay plus the bonus. And then we're going to print. We're going to say regular pay and then we're going to print the bonus pay, and then we're going to print if I can get this typed up, and then we'll print finally the total pay. One thing we have to do is we have to put this to 0, and then here we say bonus equals to 500, or what do we do times 0.1, meaning you get 10% of the sales. How's that? And then we go ahead and print total pay. So let's review this briefly. We create a variable, integer, value 1,000. We're going to create a float variable. We're going to create a bonus variable and a total pay variable that gets the value of regular pay. So let's run this program, see what happens. Well, let's start with a fresh shell. Okay, we'll go ahead and run it. Enter sales. I got 4,500 in sales. So what did I do wrong? Well, I blew up the bonus. So I will come back over here. There we go. So let's go ahead and run it again. I got 4,500 in sales. So my regular pay is 1,000. My bonus pay is 0 because the statement sales greater than or equal to 5,000. We entered the sales is 4,500 greater than or equal to 5,000. No. So then this statement does not execute. These two statements don't execute. Thus, bonus is still 0. Total pay is still regular pay, which is 1,000, and that's what prints out. Let's go ahead and run it one more time. This time with a value greater than 5,000. So I had a better month. How's that? Regular pay $1,000. I got a $500 bonus, and my pay is now $1,500. And let's go ahead and make this pretty. Format, regular pay, create me a column of 8, and we want 2 decimal places, and we'll do the same over here. So we're telling Python to format our numerical output. 8 spaces, 2 decimals, and we're gonna send you a float down the way. And here we do the same thing. We're just formatting our output so that our display looks better. So we save it and let's run it, see if we didn't make any syntax errors. I sold 5,001, and there you go. Nice, right justified output. So that's how conditional structures or if statements combined with Boolean logic, relational operators, help us build programs with different scenarios. Okay, so that was a simple statement. Let's build another one. So we're going to go ahead and open idle. We're going to create one more script. And this time let's create, so we work with an if statement. Now we are going to work with an if else statement. So an if else statement runs a piece of code if the condition is true and or false, depending on how we structure the statement. And then if that case is not true, then it runs the second statement. And let's clarify this. For example, if grade greater than 90, print excellent, you have an A. Else we're just gonna print you don't have an A. So let's go ahead and run it. See, so let's review this. So if the grade is greater than 90, then Python's gonna print excellent, you have an A. Otherwise, it's gonna print you don't have an A. So let's see what happens. Did that. Okay. So I'm sure you were all thinking you didn't define the variable, and of course I didn't. We'll make it interesting. We'll bring in an integer, input, enter grade, and then we'll run it. So our grade is 80. So Python prints you don't have an A. Is 80 greater than 90? No. So Python does not run this statement. Instead, it runs the else piece and it prints you don't have an A. We can also compare strings. Let me close this file. Well, that's not what I wanted to do. Create a file, and we're going to save it as sample3b. Save, And then we're going to show you that you can also compare strings. For example, if x greater than y, we are not comparing the variable x. What we're doing here is comparing the actual character y, or a string x, and a string y. So we're not trying to we're not trying to compare variables. And what we want to show here is if x less than y, we want to print x is less than y because the ASCII value of x is less than y. And I think they're 120 and 121, but I'm not 100% sure, so I will leave that up to you to research. But point being that when Python makes a comparison with strings, it uses the ASCII table and gets the value that x, which in this case I think is 120, and y is 121. So Python's comparing 120 to 121. What we are seeing is x and y. What does that mean? Python does numerical comparisons when it comes to comparing strings. So as you can see, x is less than y because the ASCII value of x is less than y. Easy enough. I think that's all I wanted to say about strings comparison for now. We'll revisit them later. So if we can use an if statement, then we can also use let me see, an if, elif, else. What that means is when we have several conditions that we want to test. For example, if we want to test, let me create a new file. We want file new, file, save, and this will be sample4, sample3c, sorry. And we want to ask for credit hours from the user, and we want an integer value from the input, enter hours, and then we want to check if credit hours greater than 90, print you are a senior. So let's see what happens here. We're purposely going to enter hours that are greater than 90. We're going to enter 95. So yes, you are a senior. And if we want to check if there, so elif meaning have another condition. So elif means another condition I want you to check, and then we use the same structure. This is very important right here. You always need this comparison. You need a value on the left side and a value on the right side. So is it greater than, well, let's put greater than equal to, just to make sure we get correct answers. So print you are a junior, and then we save it, and then we run it. So this time we're going to enter, say, well, it's not 80. Let me go back, sorry. So let's close it at 60. So that's how colleges determine classification. So we run it again, and we're going to enter 70 hours. So then Python tells us that that person is a junior, and then we continue building our conditional structure. This time equals to, so if it's more than 30, then we're gonna classify them as a sophomore, and then we're gonna run it, enter hours. We're gonna say 35. And Python's like, yes, you are a sophomore. Else print you are a freshman. And then we run it. We're going to enter 25 hours. And Python tells us that we're a freshman. So that's what we expected. One thing I want to point out here is that if we enter a negative number, then they're going to tell us, it's going to say that we are a freshman, like negative 90, you are a freshman. So one thing we can do is to make sure that we always get good values, we can say if we can use more Boolean logic, right, with logical operators. What does that mean? Let me go here to idle. Did I close it? Yeah. So a logical operator AND means, for example, we say true and true, then Python's like, yes, that's true. So what we're saying, true is a Boolean value. This is the logical operator and true. So we're telling Python is true and true true? Python's like, yes. So then we ask Python, is true and false? What is that? Python's like false. Okay, so what's false and true? Python's like false. And then we say what's false and false? Python's like false. So anything that has one false is false in the AND logical operator. Both comparisons have to be true for it to evaluate as true. Now there's another operator, it's the OR operator. So is true and true true? Yes. Is true or, I meant to say or right here, sorry. Is true or false true? They say, well, it's true. Is true or false or true true? Yes. What about false or false? False. So notice here that at least one true produces a true, two false produces a false. Important to know why. Now the negation operator is the not operator. So we say not false, then so if it's not false, then it must be true. Not true, then it must be false. And we're going to see situations or use cases where we can use this. The simplest example that I can give you all for this, the AND logical operator can help you in situations where you need to determine if a number is within a range. For example, if grade greater than 70, say greater than equal to 70, and grade less than or equal to or less than 80, print C. So here we want to check if a number, well, this is not going to compile because I'm missing. So let's do this. Let's create a script file. Sorry about that. So we're going to create another script file. We're going to save it. Documents, and this will be 3D. Save it. So what I wanted to do is I wanted to get a grade from the user as an integer. So input, enter grade. And then we want to say if grade greater or equal to 70 and grade less than 80, we're checking to see if the number's in the range. Then that means that this student has a C. So let's run this. Okay, integrate. 75, is it in range? Yes, it's in range. So it prints that the student has a C. If we type in 90, then it's not in the range. So Python doesn't print anything. What if we want to check if a value is in two separate ranges? I'm gonna comment this code out. And we want to say if temperature, we gotta get the temperature from the user first. So if temp equals, we want an integer, we want input from the keyboard, so we ask the user to enter the temperature. And then we want to check if it's in two different ranges. The first range, if it's less than 32 degrees, the temperature is to extreme. If it's more than 110 degrees, the temperature, we want to display the temperature is to extreme. How do we do that? So we say if temp less than 32 degrees or temp greater than 110 degrees, print temperature to extreme. So notice that we're checking if this value is in two separate ranges, numbers less than 32 and numbers greater than 110. Let's go ahead and run this. Temperature is 30 degrees. Temperature is to extreme as expected. Let's close this so we can start a new shell. We'll run it one more time with 110, temperature to extreme. But if we enter a number not in the range, like 50 degrees, then the statement doesn't print out anything, and that's expected. In that case, we could say else temperature is okay, or something like that. So let's try that. 50 degrees and temperature is okay, and that's what we expected. We could also, let me do one more example. Coming out, and then we're going to say x equals 101, and then we're going to say if x, if not x greater than 100, we want to print x is below 100. That's just that's a way we can use the not operator. Let's see what happens. So if, let me see. Okay, so we do 101, x is below 100. No, because we type 101, but if we do 99 and we run it, then x is below 100. So that's how we could use the not in Python. Let me see if I want to cover one more thing. No, that was it for this lecture.